Hey guys, in this one we're taking a look at solving harder logarithmic equations, so let's crack on. Okay, example 1, we want to solve the natural log of 3x plus 5 divided by 2 is equal to 10. So, how are we going to do that? Well, to cancel out the natural logarithm, we exponentiate both sides. So on the left, we get left with 3x plus 5 over 2 is equal to e to the power 10. And now we simply chip away everything on the left to get x on its own. So if we multiply by 2, 3x plus 5 is 2, lots of e to the 10, subtract 5, 3x equals 2 e to the 10 minus 5, and then divide by 3, x is e to the 10 minus 5, all divided by 3. And I'm just going to leave that in exact form, so in terms of e. Good times. Okay, next example, we want to solve log base 2 of x plus 3 is equal to 4. So to cancel out a logarithm, you need to raise both sides as a power of the base. So in the last example, we had the natural log, so the base was e. Here, the base is 2. So, we raise both sides as a power of 2. Now what that does on the left is leave us with x plus 3. And on the right, we get 2 to the power of 4. So, this is a nice one that we don't need a calculator for. 2 to the power of 4 is 16, so we've got x plus 3 equals 16, so take away the 3, x equals 13. Good times. Okay, slightly trickier one here. We want to solve log base 3 of x equals 1 minus log base 3 of x plus 2. So, how are we going to do this? We can't exponentiate both sides. The reason for that is because we've got a constant on a non-logarithmic term on the right and a logarithmic term. So, that's it. What happens if we get our logs on the same side? Then we can use the laws of logs to smash them together into one logarithm. They both have the same base, so we will definitely be able to do that. So, let's do that. So we're going to add log base 3 of x plus 2 to both sides. So we're going to get log base 3 of x plus log base 3 of x plus 2, and that is equal to 1. Now, on the left, we can combine our logs using the addition law. So, when we add logs together, we multiply the things inside of the logs. So, on the left now, we're going to get log base 3 of x squared plus 2x. And then that is equal to 1. So now we can exponentiate. So our log is base 3. So we raise both sides as a power of 3. That cancels out the log on the left. So we get x squared plus 2x is equal to 3 to the power of 1, which is just 3. So what we've got here now is a quadratic. We've got x squared plus 2x on the left is equal to 3 on the right. So now we're just solving a nice normal quadratic. So we need to get that 3 over on the left. So we've got x squared plus 2x minus 3 is equal to 0. Then we can factorise this guy quite nicely. We need two numbers that multiply to minus 3 and add to positive 2. So that's going to be plus 3 and minus 1. So 3 times minus 1 is minus 3. 3 plus minus 1 is indeed positive 2. Now, if this was a normal quadratic, of course we would be interested in both solutions. However, remember that we cannot take the logarithm of a negative number. Logs of negative numbers don't exist. So even though the bracket on the left would give us x equals minus 3, remember in the original question we had log base 3 of x. So that would be log base 3 of minus 3. Now that can't exist. So we are not interested in that solution. But we very much are interested in this guy that would tell us x equals 1. So x equals 1 is our only solution. Good times. Okay, last one for this video then. So we want to solve log of x squared minus 9 minus log of 3x is equal to 0. So the first thing we need to do here is combine the logs. They are both natural logarithms, so we can do that quite happily. Now, by the subtraction law, we divide the x squared minus 9 by 3x. So we get log of x squared minus 9 over 3x is equal to 0. Now we got the natural logarithm, so raise both sides as a power of e. Now that cancels out the log, so we get x squared minus 9 over 3x on the left equals e to the power of 0. E to the power of 0, anything to the power of 0 is 1. So that's what we've got so far. Multiply both sides by 3x. X squared minus 9 is equal to 3x. Subtract the 3x from both sides and we've got x squared minus 3x minus 9 is equal to 0. Now that's not looking very factorisable, so I'm now going to check the discriminant to see how many solutions, if any, there are. So remember the discriminant is b squared minus 4ac. So d is minus 3 squared is positive 9, and then minus 4ac. So minus 4 times 1 times minus 9. So we've got 9. Minus 4 times 1 is minus 4 times minus 9 is positive 36. So we got 9 plus 36, which is greater than 0. So this implies then there are two real solutions. But I don't think they're going to be very nice. So, let's use the quadratic formula to solve this guy then. So let's get rid of this stuff. Okay, so using the quadratic formula then, we've got, let's change colour, we've got A is 1, B is minus 3, and C is minus 9. So, using the formula then we've got x equals minus b, so that's positive 3 plus or minus square root of b squared. Well, actually we just worked out the discriminant. That was actually going to be positive 45. And then that's all over 2a, so it's all over 2. So, let's simplify that a little bit. We've got 3 plus or minus root 45 is root 9, root 5, root 9 is 3, so we've got plus or minus 3 root 5, all divided by 2. Now we need to be very careful here. Remember that you cannot take logarithms of negative numbers. So if we were to put in to our calculator 3 minus 3 root 5 over 2, this guy is negative. So the only solution is 3 plus 3 root 5 all over 2. Okay, now again that's because you cannot take logarithms of negative numbers, so be very, very careful with that. Okay guys, that's it for this video. Hope it's helped. Take care.